All all right, I guess we are recording. So good morning, good evening, good afternoon, everyone from wherever you are joining in. And my name is Prithvi Raj. I've been hosting the Litmus Chaos Community Sync-up calls since the last couple of years, 2.5 years. And I feel glad to welcome you all. And today we have almost a packed agenda. We'll just be covering a little on the community, and then we'll move on to a couple of important items that the community has been asking about. So without any further ado, let me just share my screen with the agenda we have on hand. So I hope my screen is visible. Obviously, we'll have a new introduction to members on the call. I see recurring folks, so I'm not sure if there are any new members, but maybe members who are joining in can take active participation in the Q&A, open floor Q&A when we talk about it. And then we'll obviously have a quick community roundup. But I see a couple of recurring folks who have been joining our calls in some time. Maybe they can share if there are any possible new updates to how they are using Litmus or what exactly their goals are. So maybe we can do that, and then we'll quickly go through a community roundup, and then Karthik will cover a little on the 3.0 beta, as we are calling it right now. The announcement blog already went out during KubeCon. We'll talk a little bit about KubeCon as well. And then obviously we'll have the helper pod optimization demo by Shubham, and then we'll move on to the Q&A. But before that, I see one of our new members, Rahul Krishna, joining us. So Rahul, maybe you can just quickly introduce yourself. Okay, I just guess Rahul dropped off. I also see one of our recurring members, Chandan. He's been joining the calls from some time now. So Chandan, would you like to share any updates you have on Litmus or anything that you have been closely interested in? All right, I guess everyone's on mute today. So we'll move on quickly with the community roundup, and then we'll move on to the next agenda items. So if you can see my screen, I'll just take you quickly through a short community roundup that I have, and then perhaps we move ahead. So moving on, obviously, a lot has happened in the community, and we have, spoken highly about it in the community as well on social media, and obviously a very successful KubeCon. The KubeCon blog will come out really soon, and I think thanks to the community members, Litmus Chaos featured in the Chaos Day. We had multiple talks and discussions from a community perspective, thanks to community members Bianca from HCL, Crystal, Raj, Vadiraju from FIS. Thank you so much for being actively involved in the community, and a shout out to them for making Litmus Chaos presence at the Chaos Day very successful. And then obviously we also had the talks, the booth, the Litmus Chaos booth saw a number of folks joining us, and the talks, obviously Raj and Nilanjan spoke about how chaos engineering or Litmus Chaos is being used as a business case in the fintech sector. And then obviously Shubham was joined by Shri from Iterate, and they spoke about SLO validations and chaos engineering. How does that use case work alongside together? The videos are live, and I'll be sharing the links in chat, and that will come out as a blog as well, which will be put out in the community. And then lastly, obviously, we had the maintainer track featuring Karthik and Uma, who just gave an update on the project as of now and how we have moved ahead. And obviously that rounded off the KubeCon for us. The KubeCon story comes out next week, and then obviously we also have a blog. But before that, I'll just share what we have had in terms of meetups and talks. I mean, the community, thanks to Dharmesh from Google Developers Group, he joined in the Google Hive Next Innovation meetup held in Bangalore, and he spoke highly about how chaos is being curated in the open using Litmus, gave out a quick demo on that as well. And then obviously community member Cyan alongside me, we joined in all day DevOps and we spoke about chaos engineering with Litmus. That was a popular talk from the modern infrastructure track. And then a couple of videos added to the playlist, the KubeCon playlist. One is the Litmus Chaos SDK demo, which was curated by Shubham. That's already live on the Litmus Chaos YouTube channel. And then secondly, obviously, a load balancer demo curated by Udit on the online boutique application, which again has been pretty helpful for a lot of community members looking for certain sample app demos. Lastly, we'll talk about the chaos engineering meetup we are hosting. As you know, Litmus Chaos Community is actively organizing chaos engineering meetups as part of the CNCF meetup groups. And we are hosting the chaos engineering meetup in person in Bangalore this time around. So in case anyone out there is in Bangalore, or you have your team or your colleagues in Bangalore, feel free to share this with them. It's on the 26th of November, and this is the stacked agenda we have, which involves a lot from the Litmus Chaos community. We have Ruben, who will be delivering the opening keynote, which features Litmus, and then obviously we'll go through a community roundup about Litmus, and then we also have Avinash, who'll cover a quick demo on API resiliency with chaos, which again features Litmus Chaos. So just in case anyone's around Bangalore or you have your team in Bangalore, feel free to drop by and just join us for the Chaos Engineering meetup at the Harness office. So thank you so much, folks. This is a quick roundup on the community. There's much more which will be out on a couple of CNCF blogs. That's the October update blog as well as the KubeCon story blog. And other than that, feel free to let us know what you have in your head. There are a lot of things we are planning to do before the end of this year. We are planning to do a CNCF webinar on the year review with Litmus Chaos, and then obviously 3.0 beta takes center stage. Maybe Karthik will be sharing more on the updates on the same. And also we'll just be doing our community events. We are also planning to work on Chaos Carnival. The Litmus community is closely involved with Chaos Carnival, and the dates will be announced soon. CFPs will open soon. So just in case you want to submit a talk on the Litmus Chaos community or based on Litmus Chaos, feel free to reach out and let us know. Lastly, a heads up for everyone who's been part of the community. The last date to submit a talk at KubeCon Europe 2023 is on the 18th of November. That's this Friday. So if you are planning to submit a talk which features Litmus, feel free to let us know, or feel free to share an idea in the community. And we hope that we can see you deliver a talk at KubeCon EU as well on Litmus. So with this, I would like to hand over the floor to Karthik. If there are any questions, feel free to ask them in chat. And Karthik, maybe you can share further updates. I'll be sharing the other links on chat.
Thanks, Prithvi. I think that was a pretty comprehensive community roundup. It's great to see all the activity in the community, all the support it's receiving, and generally the awareness and increasing practice around chaos engineering itself. So thanks once again. Let me share my screen. I hope my screen is visible.
Yes, Karthik.
All right. So I just want to give a little bit of a background on why 3.0 now. What is really the motivation for the major version upgrade and how we are going to go about it. I'll take a few minutes to sort of set the context and then talk about what exactly is coming in 3.0. And going ahead, in the next part of this call, Vedant will run through the release notes of the first couple of beta releases, the beta 0 and beta 1 that we already have. Okay, so as you all know, I think the folks on this call, most of them have been long-time users of Litmus and have seen the project evolve over the past couple of years. Initially, the objective of the Litmus project was to provide a Kubernetes native approach to doing chaos engineering, which meant we created CRDs to describe the fault and operators that could reconcile these CRs, essentially automate your chaos experiments in a Kubernetes native way. That was really the objective. And we built up a suite of commonly used or commonly seen outages or faults. We call them chaos experiments and then put them inside of the chaos hub. Right, the chaos hub is the open catalog consisting of several chaos experiments based on category of targets, mainly focused on Kubernetes. That's what we got done as part of the 1.x version of Litmus, and we had it running till 1.13. And at that point, by then we received feedback from the community on simplifying the process of running chaos on a fleet of clusters. So in the original 1.x release, we had operators that had to be manually set up, manually as in either via Helm charts or via manifest applied via kubectl by the SREs or developers, and then apply your chaos engine CRs by hand to get the chaos going. But you would have to do it repeatedly on every cluster which hosted your business applications. And it was not very friendly for enterprise usage. It was not possible for teams to collaborate on different environments on a single platform. So all these things were addressed as part of the 2.x release. With 2.x, we brought the concept of a control plane and an execution plane. You had a dashboard in which you could create teams, invite users, attach other clusters. So you had a single pane of glass management where you could connect different clusters onto a single dashboard and manage chaos from there. And we also provided some API which folks could use as part of automation efforts, calling the chaos from pipelines or calling it from some kind of scripted platforms. And once we had this going, we ran till 2.14. We had about 14 point releases or minor version releases in the 2.x program. And this stage has come for us to optimize and make the functioning or operations of Litmus more efficient. By that, we mean how we can improve the orchestration capabilities, how we can make Litmus run with a smaller resource footprint, how we can help the new persona that is embracing chaos engineering, that is the developers. Traditionally, chaos engineering has been the purview of SREs and to a certain extent QA teams. But as the process of left shifting continues, as chaos engineering is seen as more relevant in the pipelines, we have a new persona entering the space, that is the actual cloud native developer. And the idea is to make execution of chaos experiments and also the observability around it simpler for this persona. So that is going to be really the agenda for the 3.x program of Litmus. So we got started with beta, just as we did with the 2.x release. We're going to have an extended beta for 3.x as well. What that means is we're going to run beta releases over the next few months, at least for the foreseeable couple of quarters, and take in feedback from users on what we are thinking, and take feedback on any improvements that we can make, keeping in mind the goals of the project, the 3.x version of the project. So any improvements in that area, we will actively gather feedback and implement it before going GA. Right. So those of you who are interested in being early adopters of the 3.x, you can download the beta version. You can also upgrade from the 2.14 or the 2.x version that you're on. into 3.x beta. We will provide some guidance on the Slack channels around how you can do that. That's really the background and the context around 3.x. Now, coming to what exactly are we looking at when we said we are going to make it more efficient, less resource footprint, and better for developers. What do we mean by that? What are the features which actually are going to help with these things, right? So we'll go through that a little bit. I'll take a few minutes to do that, and I can take some questions around this before we hand off for the release notes walkthrough. So under the robustness agenda, we've got a couple of broad items. Improved chaos orchestration, right? So today we are using Argo workflows. The Argo workflows are great as the workflow engine that is powering the chaos workflows. You can stitch together different tasks, tasks to create chaos, tasks that run load, tasks that probably do some kind of result pushes into an artifact sync, or any of these kind of custom tasks. And Argo is also a project which is thriving in the CNCF, so we felt it was a very great fit for achieving our workflow goals. One of the other things that Argo brings in with it as a trade-off is the fact that each of the tasks needs to run out of a separate pod. That would mean there's going to be a lot of pods created as part of an experiment run. It's all right in some cases, but in some other cases where the environments are less resourced or the environments are transient in nature, you would want something that is faster and not having to churn, not having to cause too much churn with many pods getting created and deleted. And also Argo workflows, while it provides a CRD and it is in essence a declarative model of defining your tasks, it also allows for running certain scripts, we basically took advantage of that to do certain actions within our workflows. And this can have an impact on what happens when there's evictions, when your node goes down, or there's an accidental kill of some of these Argo pods that are carrying out the experiment, etc. So the system can enter a state which is probably suboptimal and needs a little bit of manual intervention to clean up before we proceed. Some of that we plan to address by bringing in some modifications to the workflow engine. And that's something that we are going to work towards. There will be changes to the core execution infrastructure as well to accommodate this. So that's one of the items, improved chaos orchestration. Next, we come to Helm-based automation. Today, the control plane is implementable or deployable using a Helm chart, whereas the agents or the chaos delegates, as we call them now, have to be set up by following a process that involves downloading a CLI tool called LitmusCTL, providing the inputs for the control plane endpoints and authentication, and you basically provide all inputs as to where you want the agent installed, etc. While this is not a bad approach, this means that the user is not having a fully automated experience in setting up Litmus, right? So there is a little bit of manual activity involved in doing the CLI operations. And also there is another requirement. When you use LitmusCTL, you're not really looking at the YAML, the execution components, the workflow controllers, the subscriber, the operators, the event trackers, etc. You don't really see those manifests. It just gets deployed, and then you'll have to tweak whatever you'd like to tweak. You will have to do it post-install. So we want to avoid that. We will be providing a Helm chart for the agent as well, the execution plane. So you can then just use a Helm file where you're setting up the control plane and then the execution plane also in one shot. The execution plane chart will be equipped with a few pre-hooks so that you're able to do the authentication and other activities. So this is basically going to increase the automation. And where this will help is, let's say you're bringing up a cluster and you would like that to be chaos enabled right from the get-go, you will be able to do that with the execution plane Helm charts. So that's the improvement we are making in terms of Helm automation. And the UX is, we got good feedback on some of the improvements that we need in the current UX, how our dashboards can be better, some of that is going to be included as well, especially in the areas of what is the impact an experiment is going to create, right? We know the experiment progress. You have the graphs that are telling you what part of an experiment is running, what stage of an experiment is running. But it will be great to know some more details around what's going on in your target environment when that experiment is running. How do we bring that info back to the dashboard? Some of that is here. And talking about resource footprints, you all know about the helper pod model in Litmus. Whenever you're running the network or stress chaos experiments, you would see some pods, transient pods that get created on the node where your applications reside. And these run with certain privileges, as you know, in order to run the container runtime APIs. So these pods today, the helpers are per target based. What we mean by that is, let's say you have an application deployment with 5 replicas, and you've set the pod effect percentage to 100, which means all 5 replicas of that particular deployment are potential targets to undergo the network or the stress pod, resource stress pod. So we today launch a helper pod, one helper pod for each replica, which can be quite a lot, especially as you scale chaos. So we are bringing in a better scalability by introducing this concept of a per node helper. So you'll have just one helper pod, one transient helper pod that gets created on the node, irrespective of how many replicas you have sitting on that node. So we decided against a dimension model, like I think we discussed in our earlier calls, because we don't want to be running privileged dimension pods all the time. We want to make it just-in-time execution. So that's some of the things we're doing around making it leaner. And coming to how we are going to enable the developer persona, some of you might have noticed that we do have a repository called Chaos CI/lib. That is essentially the wrapper around the Litmus Chaos experiments, which gives you a BDD kind of an interface for you to run experiments from pipelines. But this is today only working on the 1.x version of Litmus. So we will be making efforts to make it compatible with workflows and the new set of constructs that we introduced in the 2.x. So it's basically going to help you run full-fledged workflows as part of your dev pipeline execution. And the code base for the experiments, the Litmus Go, will be made more modular. It is going to be simpler for developers to come and make changes to the experiments or generate newer experiments via an improved SDK and help with accommodating more varied kind of experimentation than what we have today. So there's going to be some significant refactor that we will do for the experiment code base. So these are some of the high-level things. Of course, each of these topics or agenda items will come to have more specific sub-features, which we will talk about as we go through the beta releases. So with that, I'll probably stop. I hope I've given enough context on what we're looking at doing as part of the beta program. I can take some questions around this and then hand it off to Vedant after that.
Hey, Karthik, this is Raj. This is awesome. You're heading in the right direction. Quick question on that improved chaos orchestration. Are you replacing Argo with some other workflow tool, or you continue to use Argo but simplify the workflow and in terms of number of parts it creates, etc.?
Yeah, that's a great question, Raj. We are looking at keeping Argo as well as provide the ability to use some more native workflow engine. So it will be up to the users as to what they would like to use, depending upon the use case and the environment they're deploying Litmus in. Argo comes with a lot of benefits, like we spoke about, which is something that we would like the users to enjoy, while we also set up alternatives for a more leaner kind of an execution. So yeah, so you're right about that. We're going to keep Argo as well as provide a native model of running the experiments.
Okay.
It's going to be a choice when the user is constructing their workflows.
Yeah. And also, maybe I missed earlier when you're explaining the 3.0 in general. you planning to have a non-cloud native agent as part of this release, right? Is that the plan?
When you say non-cloud native, are you talking about some legacy infrastructure, Raj?
Yeah.
Agents
Yes.
for non-Kubernetes kind of workloads. Yeah. So we do have a project called the M Agent, where we have put up a basic framework for how you can enable chaos inside of Linux targets, irrespective of which platform it is on. So that M agent will basically be equipped with some amount of documentation, some more information on how you can build on top of it. And we are basically going to seek some community contributions on it. So that's really the plan around the non-native agent for now.
Okay, all right, thank you.
Cool. I'll probably stop sharing. Thanks for giving me a patient hearing. I think Vedant, over to you.
Yep. Thanks, Karthik. So, hi everyone, this is Vedant. I'm a senior software engineer at Harness. So I will just give you a walkthrough of the release notes that we have done this release as well as the previous one. So I'm just sharing my screen. So maybe we can just start with the beta 01. So beta 0 is like we had these release notes. It was our starting of 3.0 release version. So these release notes, takes you through what are the different aspects of the changes that we have done till now, and what you would be expecting more in the upcoming releases as part of our roadmap. So just start with it. So first one, it's like there was an introduction of HTTP chaos experiment suite. So if you have been with us for a long time, you might already be knowing that we started with HTTP chaos experiments with one experiment that was HTTP chaos latency. And now if you see, we have gone to around 4 to 5 experiments, right? 4 to 5 HTTP chaos experiments. And that also, we have been making some enhancements here and there with respect to different fault inputs, like with respect to, having a fault, not fault, input toxicity, randomization doing there, and, different types, even in the modify body, if you see, we have an enhancement being done on content encoding and type and all, right? So this was like, this was our first step into HTTP chaos experiments. You might see some, more experiments coming into different categories with respect to HTTP chaos. So next is support for network and stress chaos experiments on new versions of Kubernetes. So with the these 1.21 release of Kubernetes, and even with the OpenShift in OpenShift, when we go above 4.x, right, there are some changes with respect which have been done with respect to CRDs, deprecation of some of the CRDs which were having API versions in V1 and Vita 1 groups, right? So with respect to that, we have made some enhancements in the network and stress chaos experiments so that we can support there as well. And similarly in OpenShift also, there have been some changes with respect to the security-based CRDs or the strategies that we follow there, right? And yeah, that's there. So next is support for network chaos experiments on service mesh enabled environments. So yeah, this was one enhancement that we had done in our prior releases. So if you might be using, you might have used our older versions of Litmus within the service mesh enabled environments, you might have seen, we were able to see the effect on Istio based containers, but application based containers were somehow not getting, getting affected. So this was one enhancement that we had done so that to now these experiments are, enabled for service enabled environments also. And as we have written here, right, network latency, loss, HTTP, DNS, these all the categories we have, made enhancements there so that you can run those experiments on the service mesh enabled environments. Similarly, there have been some enhancements. We have provided some inputs in different files with respect to randomization of different inputs, so right. And then, so when we did this 1.2, when we upgraded our component with respect to 1.21 plus release of Kubernetes, right, we also upgraded our client Go version. So with that, we also upgraded our operator SDK version. So with that, our chaos operator was also upgraded, and now we also support HA of chaos operator. And then from the LitmusCTL point of view, since like this has been a we have been getting many requests with respect to some users want to run the workflows using API, or some users want to run the workflows using CLI tools, right? Because from the UI, like it's a manual effort, and you want to run some you want to automate some of the operations through CLI commands or API queries. So this was the enhancement that we had done with respect to LitmusCTL. So now you can trigger workflows or list workflows or delete the workflows using the LitmusCTL itself. Then there was a regular query with respect to DNS chaos experiments. We only had support for Docker runtime, but now for DNS and HTTP both, now we are still moving some enhancements, but still now we have support for containerd and CRI runtime for DNS and HTTP chaos experiments. Moving further, so yeah, Litmus SDK. So Litmus SDK, it's like we had support for generating experiments based on helper pods. Now we have support for generating experiments based on ESAC. And also now we have also templates for generating non-K test based experiments. And upcoming ones, you might also see that you might also be able to generate experiments along with the probe specification using Litmus SDK. And then we might be introducing some more faults with respect to Kubernetes. So you might be you will be able to target some storage volumes with the same. This is like one example. There will be coming some more in the same category. And then, yeah, this was one of the requirements. So usually currently, you're using our command props, like we are making some enhancements there so that, we can provide some more inputs around the same to make the hypothesis more powerful. Next is with respect to API. So this is also the same, like, some users now, I think now most of the users are also using chaos server APIs to trigger workflows or to connect different chaos delegates or many other operations, right? So in the last releases, we have been doing different improvements in different chaos server APIs. Now we have a standard standard schema, or I would say a format that we follow for all our queries. We have introduced request type of inputs and response type of as part of our responses. And similarly, with all these enhancements coming in and all the changes that we have been doing, we have also been making improvements in our automated E2E test suites. On like till now, like we started with we had a Litmus core experiments. For that we had our E2E test suite, and then we generated E2E test suite for Chaos Center, and then with some contributions from LFX and many other operations, we also got contributions in as part of API test and other things. So that was also a good contributions that we have got. And similarly in Litmus talks, now we have the Litmus usage tutorials, which are now deployed on Google Code Labs. So in case you haven't seen it, you can check our documentation. There is a tab tutorials. So now different tutorials are available for different user stories. So this I would recommend you should definitely check them out. And then with respect to execution privileges and simplifying docs, so in OpenShift we have been getting queries to make our PSP definitions a bit simpler. And on the other thing on the OpenShift side, mostly on the OpenShift side. So those are the also the different improvements that we have done on the documentation side, and we have provided different comments there as well, so that it's easier for the users to know which permissions are required and what is the objective for the same. So this was like beta 0 release notes. This was like what changes we have been doing and what other changes which might come as part of our roadmap. So do we have any questions with respect to that? I can take them. Finally, I will just scroll to the latest release. Okay, I presume there are no questions. Okay, so yeah, on okay, I think okay. So yeah, going with the latest release, beta 1. So in this release, we have done some of the improvements with respect to experiments and to simplify the executions. So firstly, I will go with the improved scalability in the execution network and stressed chaos experiments via helper pod optimization. So if you have used a stress chaos and network chaos experiment, you might already be knowing, right? If you are targeting one pod, then for that particular target pod, there comes a helper pod, right? So if you have a deployment which is having 40 or 50 replicas, right, in that case you might see that there are 40 or 50 helper pods coming in, right? So to optimize that, and like with that case, you might also face the resource consumption issues and all. So to tackle the situation now, you don't have to the experience won't be creating helper pods for all the target pods. Now the helper pods will be created based on number of nodes. So on every node there will be one helper pod created, and your target pods will be injected with chaos accordingly. Next one is Spring Boot applications. So now we have introduced a different a new experiment category for Spring Boot experiments. As part of this category, we have introduced 5 experiments. So if you see, I can just show this area. So now we have a Spring Boot app kill experiment. We have CPU stress, we have exceptions, and then latency and memory stress. So if you want to check them out, please definitely check them out. Then yeah, in KTest probe, if you have used, we have you might know that using the KTest probe, we can select different resources using labels and field selector and do some other KTest operations with respect to get, set, or delete. But now you can also select your resources with, by giving the resource name. So there is a new input now introduced as part of KTest probe. So we can set the resource name also in they label and field selector and resource name are mutually exclusive. So accordingly, it will work like that. Then similarly, going to the next one, in experiment helper based images, so we were seeing that there was some regression that we saw with respect to execution of privileged tasks. So that was also fixed as part of this release. There were some enhancements that we had done in the Docker file with respect to this one. And then yeah, so this one is also there. So now we have removed the annotation check. So now if you want to target some application, you can just provide the app info, and based on that, the particular target application will be targeted. And then this one, I think you might have already seen this queries many times. So it's there was a race condition that we have been facing with respect to execution plane components. So generally it was you are scheduling some workflows from the UI, and they are not getting triggered on the cluster, although they are there in the cluster, but they were not getting triggered. So that was because the workflow controller is the one which triggers the workflows, but the workflow controller reads its configuration from this config map, workflow controller config map. So if the controller config map is created after the deployment, then it can create issues. So it was getting fixed when you restart your workflow controller config map, but this now race condition will not come in by this release, where we have fixed the race condition now. So by default, whenever you are deploying your execution plane components, or I would say chaos delegates, this issue will not come there. So yeah, that's all on the beta 1 release notes.
With that, couple of questions.
Okay.
So the first one, the very first item where you have now only one pod at the node level that you create, helper pod, right? So I'm trying to understand. So if I have a pod delete experiment, right? And if I'm trying to set up a probe, I think you internally have some sort of a probe, right? Whether a new pod is created or not, right? You're checking that. How does that work? How does helper pod know a new pod is created? Because the new pod is created by Kubernetes, right? Litmus or helper pod does not know. How, are you querying the Kubernetes API and trying to get it? If so, in the case of like these 5 pods, if they have 5 application pods, if you're dealing 5 pods, how does it work? Trying to understand that a little bit better.
Yeah, so like I can just take some part of it. So yeah, so Raj, this improvement that we have done, it's only for network and stress chaos experiments, right? So like it's only for those experiments which actually include the creation of helper pods. So the case that we have, right, the example that we have discussed, right? So pod it actually doesn't include the like creation of helper pods. So yeah. Yeah.
Oh, okay. I thought, okay. Okay, right. So it create a pod, but not a helper pod. I get you.
But but the question that you asked, Raj, so philosophically, I sort of get your query. Yes, so we do use Cube API today to identify the new pods. Even in the pod delete experiment, when you're killing it and there are new pods that are coming up, their details will be derived by executing the Cube API today. That is true.
Got it. Yeah. Yep. So based on the label, a query or deployment, whatever you query, the new pod is created. Get the list of parts and check the maybe lifetime or whatever, right? Or what is the new part, and then you determine if there's new part created or not for that particular deployment, right?
Right.
Okay. Actually, second question is on the Spring Boot. So when the Spring Boot, a chaos experiment around Spring Boot, you mean like, introducing some sort of a memory, pressure, CPU throttling on the JVMs? Is that the idea? I'm curious about those process level experiments that you have just showed for the Spring Boot applications.
Yeah, you're partly right, Raj. So we would have hooks within the application. So when you're basically building your application, you would do so with certain hooks, which are activated during the experiment execution time to cause some of the attacks that you just spoke about. Shubham can probably give you more details on some of the attacks that we're supporting as part of 3.0 beta 1. Shubham, would you like to take that?
Yeah, so basically, the pod CPU and memory is same what we are doing in pod CPU and memory. In case of there is an exception, so if you will inject the exception, so as Karthik sir mentioned that we're like while building the image we are adding some hooks. So whenever you are calling that API, it will automatically, based on the argument, it will give you an exception for that API. There is a app kill also. In case of a app kill, it will restart the container. So we are not restarting the container from outside. We are not running the Docker stop or CI/CD stop. Instead, it will implicitly it will start from the code side. And I think the third one is network latency. So the latency is also similar to our pod thing. So whenever but it is specific to a like API level also you can do. So if you will provide some specific vouchers or class, then it will do the latency only for those APIs. It will not do for the whole pod. For example, in case of a Kubernetes pod network latency, so you will see net latency for the whole application for all APIs. But with this, you can do at API level.
Class level. Sorry, you can.
Yeah, class level also.
Got it. Got it. But can you expose it like an API level, like a Spring Boots, maybe exposing, maybe say a CRUD operation, right? Create a put or a get and an update and delete or something like that, right? So can I introduce latency on a specific endpoint, a specific API?
Yeah, we can do a specific API. Correct. I mean, there are a lot of other options also. I mean, if you will explore the experiment, so it is not just class. So there are some in Spring Boot REST controller also there, and there are a few more options are also there. You can do for I mean, not only API, there are other options as well.
Okay, got it. And the memory pressure that Vedant just showed briefly. So is that memory pressure is like creating some sort of some objects in the JVM heap memory, or is it outside of JVM heap? I'm trying to understand that a little better.
I think it is inside the JVM heap only.
Okay.
I mean, yeah.
Okay. Yeah, that's good. Actually, that's missing functionality. Actually, I was about to write a PR or something like that, a feature request, and looks like you're ahead. Okay, I'll explore this a little bit more. Thank you.
The great news about this one is it's actually come from the community, Raj. So this is basically contributed by Orange. So that's probably another nice facet of this particular functionality that we've added.
Okay.
We hope to build more of these attacks on various application types. Spring Boot is probably the one that we got started with, as it is a common example for chaos, but there are other application types that this might extend to in future.
Yep. I mean, I would recommend, like, you could separate that out into Spring Boot and JVM based experiments, right? Because if there's a JVM specific experiments that you have, it could be a Spring Boot or it could be some other application, right? Running on JVM, right? So you can generalize that way. And if there's a very Spring Boot specific one, then you can put those experiments in that category. Okay, good stuff. Thank you.
Thanks, Raj. I think those were great questions. I think we've gone through what's coming as content. We can probably do a quick demo of the first one, how with network or stress experiment, even with multiple replicas spread across nodes, you would just have a single helper. Shubham, you want to share your screen?
Yeah. Hi, everyone. I'm sharing my screen. Yeah, so as you already know that in most of the pod level experiment, we are launching the helper pod to mount the socket path or to run the privilege pods, or because we want to run on a helper pod on the same node where the target pod is there. So that's why we were launching a helper pod on all nodes, like it is one-to-one mapping with the target pod. So wherever the target pod are there, we are launching the helper pod on the same node. So the limitation of this approach was in scaling environment, when we have a multiple replicas, then it was launching a lot of helper pods. So as Vedant mentioned, that it created a resource issue. Also, the pod quota also will extended if the number of target pod is very high. So to optimize this, we were launching, independent of the number of replicas, we are launching one helper per node for the chaos duration, and when the chaos duration is over, we are deleting those privileged helper pods. So so as part of this demo, I have an Nginx application with 10 replicas, and I have a 3-node cluster, and all these replicas distributed all over the node, and the chaos center is already installed. So so this feature is as part of the 3.0 beta 1 release. So I will just run the this feature is for like pod, CPU hog, memory hog, stress, network experiment, DNS, disk fill, container kill, and all those experiments where we are launching the helper pods. So I will just run the pod CPU hog memory experiment for this pod. So I'm selecting the Nginx pod, which is deployment, which is running Nginx namespace. I'm running for like all replicas. So I provided pod effective percentage is 100, and it is containerd environment. So I provided the runtime at containerd and socket path as containerd socket path. So the experiment is running. Also here in the left side of the terminal, I have running the I'm watching for that kubectl top pod command to see the resource uses for all the pods. So if you can see, it launches the 3 helper pods. So because we have the 3 node cluster and all the replicas are distributed on all nodes. So it might take some time to reflect on the this one kubectl top command. Yeah, you can see the CPU is increased for all the replicas. And here the total cache duration 60 seconds. So it will after 60 seconds, it will revert the chaos. You can also see the logs here.
One of the big benefits of this is when you're really running experiments on environments which have hundreds of replicas. For example, you may have 50 replica deployments, 100 replica deployments. This is not uncommon in production scenarios. For really traffic intensive pods, you might have autoscalers which are launching pods, and there are a lot of pods that get accumulated over time. And you might want to be doing chaos during game days to take down a significant percentage of them. And this feature is going to be really beneficial in order to cater to those kind of environments, do chaos against multiple replicas with just one helper. So that's really the benefit and the demo. Thanks, Shubham. I think this is a really useful feature. And we can probably take some questions around this, if any. Okay, I think with that, I think we're done with the agenda. Prithvi, do you have anything to share with the community before we wrap up?
No, Karthik, I think we are good. If anyone has any generic questions or anything to share, we can just have a minute for that, or else we are good to wrap up for this call. Right, folks, I see none. So I think you can wrap up for today, and for any other questions, feel free to post them in the Litmus Chaos channel. And thank you once again for joining in and being actively involved with the community and being a crucial part of it. Thank you so much, everyone. Have a great day or a great night ahead. Thank you.
Thank you. Bye, everyone.